We now have this tiny little electrical device that many people will be like, Mr. Steckler, when am I ever going to need to use this in my whole life? All the way to, I know I want to make sweatshirts for Etsy, and I could use this to make sure my color matching technique is precise in my tailoring so that I'm making outfits that accurately portray what consumers want to be using and wearing to showcase to the world. So you can see I'm really getting into this, what I wouldn't be able to do with Google. Welcome video 1 of how I've been using AI to help make my life as a computer science teacher and my students' lives better. When would I, as a 7th grader, so on this little short episode, I'm going to talk about this project that my students are doing. So all students, all 200 of them, have a Raspberry Pi mini computer, and they're learning physical computing to learn how physical components can be controlled by computer software that they write using Python. And in this project, they're learning how to create a simple circuit where they're using little LED lights, and they're using resistors, and then they have the jumper wires to connect it to the pins on the Raspberry Pi, which is just to say that they're using basically a lot of electronics. Some of those electronics we don't fully understand. So in the baggies, the colors on these little resistors, these resistors which are being used in order to make sure that these light bulbs don't burn out, all have these different color bands on it, which actually means something. So according to the baggies, I've known and I've been telling students, you got to use over 65 ohms of resistance so that the light bulbs are safe to use. Now in the bag, these resistors are both 100 ohms. So in the past, I've just been like, those are safe to use, that's all you need to know. But students were curious, and I did a deeper dive into like what's going on. And I didn't exactly know the full answer, even though I looked it up. So I went over to ChatGPT to try and help me explain so that I would have better answers. What is the key difference between these 4 and 5 band resistors? So it told me it lies in their precision and the way resistance values are indicated. I started reading about the 4 and 5 band resistors, which made a little bit of sense. Like it's able to make them more accurate. So I Googled then a calculator that I could look up the color bands. And the first one that has this tan outside is colored, we have first brown, black, brown, and there's only 4 of them. So I went to 4 band, brown, black, brown, and then tolerance is golds. And that's a resistance value of 100 within 5% plus or minus for its tolerance. So it's within 5% of this value, it's going to be accurate. So maybe call that from 95 to 105 is how true to how much it's actually going to absorb, which is still safe for it to not explode, which is good. We don't want these lights to burn out. For the 5 band resistors, we could look up that one under 5 bands. And this 5 band resistor is different colored, and it's a little bit harder to see, but it's brown, black, 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 brown. So brown, black, 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 brown. So I can see the first band stands for the 1, then we have 0, 0 to stand for 100, and then the multiplier of black means it's still staying at 100, but now the tolerance is within 1% of accuracy, so 99 to 101, which is going to be useful if you ever need to make a circuit that really needs electricity that stays within a certain range for its tolerance. By using ChatGPT and reading about this, I'm able to have a better understand of what these 2 little resistors are, and then also get a better understanding of what does it mean for precision, which I couldn't have explained before this video. So standard tolerance of plus or minus 5 means that they're less precise compared to the 5 band resistors. So 5 band resistors, when you need precision, are going to be better to use because of that lower tolerance. You can also see that 4 band resistors are used in general applications where high precision is not critical. So maybe we want to learn more about this. We're curious. We're like, all right, so what actual situation, when would I, as a 7th grader, need to use a 5 band over a 4 band resistor? And instead of having to dig through some sort of Google query where there's a lot of answers and no thing that's tailored exactly to what you need, you can tell them a little bit about who you are, obviously not giving personal information, and then help it connect to what something that you might do. So let's see what it says. I'm going to tell them the parts that I have available to me. I have a breadboard, lights, button, potentiometer. So I'm going to tell it the parts that I have and see if any of those would benefit more from a 5-band resistor. So the difference is generally not critical. LEDs are usually not highly sensitive to the precise value, so we're okay with those. Button, it's not critical for. For the potentiometer, it's less critical. So for this one, it's a little interesting, the light sensor. While precision can be more important, especially if you're measuring light levels accurately for basic learning projects, it's often sufficient. When would I need it to be highly precise with a light sensor when maybe it's used for safety purposes. So you can see I'm really getting into this, what I wouldn't be able to do with Google. So here's some examples where a 5-band resistor might be necessary. Automated lighting systems. System that control lighting based on ambient light levels such as street lights or emergency lighting in buildings. Precise measurement of light intensity is essential. Incorrect readings could lead to lights not turning on when needed, posing safety risks. So the street lamps that we have on the public streets in the United States, we certainly want those to turn on if the light level drops, maybe it's a snowstorm or a rainstorm, and we want to be able to see because cars are dangerous things on the road. Security systems. Motion detectors or perimeter security devices. We definitely want that to go off if something might be hitting that security barrier. We have occupational health and safety. Photography equipment. Professional photography. Yeah, like imagine doing someone's wedding. You don't want the light measurement to be off and then all their photos are ruined. So we can really get into finding like a specific application, and maybe even, I don't know if this is going to work, but we're going to push this. What if I want to be a tailor? I know it might not be needed, but give me a specific example of when it would help. So like tailor it to what you know you're interested in. So let's see if we can come up with a hypothetical scenario to apply it to our real world example. So automatic color fabric matching system, a light sensor based system to precisely measure and match fabric colors. So like making sure that if you're like making a specific outfit, you want to make sure that those match. So you could use a microcontroller to suggest those matching colors from your inventory to make sure that that purple you think is purple is actually some other hue or shade of that color. Ah, that's really interesting. So like I could never have thought to look this up, but by asking the right questions, we now have this tiny little electrical device that many people will be like, Mr. Steckler, when am I ever going to need to use this my whole life? All the way to, I know I want to make sweatshirts for Etsy, and I could use this to make sure my color matching technique is precise in my tailoring so that I'm making outfits that accurately portray what consumers want to be using and wearing to showcase to the world. Pretty cool, huh? So in this series, I'm going to continue to go into how I'm using AI to help me out. You'll notice that in this video, I was using GPT-4. There's a lot of tips and tricks that I am going to be showing you guys in future videos, so make sure to hit that subscribe button. And if you have any questions, please drop it in the comments. I'd love to hear any ideas or questions that I could use your ideas as launching points for. So hope you guys enjoyed this video, and I will see you guys in the next one. Peace.